Welcome! Each month I make a summary of the solar activity in the previous month, and this video covers the month of May 2020. The conclusions you can draw from this at solar cycle 25 is well underway, and if that is the case, we can certainly cancel any further discussions of a grand solar minimum for at least another solar cycle. The Sun is undergoing a magnetic transition from solar cycle 24 to solar cycle 25. Solar cycle 24 peaked in April of 2014, as the picture shown here on the left. You'll notice there's a large number of very bright areas. These are called active regions and are generally associated with strong magnetic fields and sunspots. So there was a lot of sunspots at that time. You can see how bright the corona is and how far it stretches away from the solar disk. Also, the polar regions are not particularly visible at this time. Fast forward 5 years to solar minimum, which I estimate to be in September or October of 2019, and you see a very different picture. The corona is much dimmer and doesn't stretch so far out into space. The polar regions are very well defined by two dark areas. These are coronal holes, which are the source of the high-speed solar wind. Since then, solar cycle 25 has started to assert itself. And the million-dollar question is going to be, how big will solar cycle 25 be and when will it peak? We're going to start this review by looking at a magnetogram movie. That's a movie of the magnetic field on the Sun. And so first I should explain how to read a magnetogram. This is an example of a magnetogram from the HMI instrument on the Solar Dynamics Observatory. To give you the orientation, north is at the top, south is at the bottom, east is to the left, and west is to the right. The Sun rotates from east to west in the direction of the arrow shown. I have 3 active regions circled here on the disk. So let's determine whether they are old or new cycle. If they're in the northern hemisphere, as all 3 of these are, if negative polarity is leading, then this is a solar cycle 24 region. The negative polarity is marked by the darker color, and so therefore all 3 of these are obviously old cycle regions. If positive polarity is leading, that's the white color, then it would be solar cycle 25, and we don't have any such regions on the disk at that particular time. In the other hemisphere, in the southern hemisphere, that convention is reversed. Another way of telling whether a region is old or new cycle, though less reliable, is how close to the equator it appears. Old cycle regions tend to appear closer to the equator than new cycle regions. So all 3 of these regions are also close to the equator. So that would pretty much wrap it up, as all 3 of these cycles are old cycle regions, i.e. solar cycle 24. So now let's take a look at an example of what new cycle regions would look like. Here we have another magnetogram, but just taken a few days ago. We have 3 regions marked again. Now look at the region in the northern hemisphere. You have positive polarity leading, and by the convention that means that would be a solar cycle 25 region. In the southern hemisphere we have 2 regions marked, both of which have negative polarity leading, and these would therefore also be solar cycle 25 regions. And just bear this in mind while we look through the magnetogram movie for the month of May. The next movie we're going to look at is the helium-304 movie, which is equivalent to about 50,000 degrees. Now that's about 10 times hotter than the surface of the Sun. These images were taken by the Solar Dynamics Observatory AIA instrument and have been sped up such that 1 day equals about 1 second. The next movie we're going to look at is that from iron 12, which is characterized by a temperature of 1.2 million degrees. This is in the corona of the Sun and is the low temperature corona. The temperature is high enough that all the plasma is ionized and therefore outlines the strong magnetic fields. So these loops you're seeing here on the left hand side of the picture are magnetic fields. They're generally associated with bright areas on the surface of the Sun and therefore called active regions, and therefore sunspots. Note how many of these cross the disk during the time of the movie. Also, dark areas are coronal holes. They are open magnetic fields and are the source region for the high-speed solar wind. The next video we're going to look at is that of iron 16. This is a much higher temperature line showing plasma at about 2.5 to 3 million degrees Kelvin. So this is the high temperature corona. So we're going to see the active regions and sunspot regions much more clearly in this line than in the other ones. The last SDO movie we're going to look at is that of iron 20, which has a characteristic temperature of about 10 million degrees. Now this line is contaminated with some lower temperature lines, so you can see some of the cool lines as seen in the iron 12 pictures earlier. But where you see bright kernels like the one shown in the bottom left of this picture, you're going to be looking at flaring plasma. Last, but by no means least, we look at the Soho coronagraph movie. The dark circle here is the occulting disk which blocks out the bright area of the Sun, and the actual size of the Sun is shown by this disk in the center of the image. What we're looking at beyond that is the outer corona, where we're looking for ejecta such as coronal mass ejections. And there are several quite nice ones during this movie if you look carefully. During the month of May, we had two large M flares right towards the end of the month. You may have just caught them at the end of the Iron 20 movie earlier. But these are the first M flares of solar cycle 25, and is a very promising start to that cycle. Well, let's take a look at the course of solar cycle 24. It started sometime in late 2008 and has gone on to 2019. Now I estimate minimum was somewhere between June and December of 2020. So I'm putting this minimum at September or October of 2019. Now we're going to have to wait at least a year before we can actually confirm the date of minimum. But from that point onwards, we should be seeing an uptick in the amount of solar cycle 25 activity. And in fact, that's exactly what we are seeing. The Sun is in the process of switching from solar cycle 24 to solar cycle 25. the first half of 2019, we had 10 solar cycle 24 regions, 10 in the north and none in the south, and just 4 solar cycle 25 regions, 2 in the north and 2 in the south. In this first half of 2020, we've had 3 solar cycle 24 sunspot groups, 1 in the north and 2 in the south, and 17 solar cycle 25 sunspot regions, 8 in the north and 9 in the south. This says that there's a major transition going on at this particular time. Before 2019, the first half of 2019, we had 71% of our regions were sunspot cycle 24, and after that low period of sunspots, we've had 84% of our regions be solar cycle 25. After the beginning of 2020, we've had 84% of our sunspot regions be coming from solar cycle 25. We hear a lot on YouTube about the official NASA prediction of the solar cycle being either very low or very high or whatever. Now, the official prediction from these agencies, NOAA and NASA, is very different from the individual prediction of a scientist either working for either of those organizations or getting money from those organizations to do solar cycle research. This is the official NOAA-NASA forecast for solar cycle 25, at least at the moment. The red line shows what they are actually predicting, the mean of all their predictions, which is slightly larger than solar cycle 24 and will peak in the middle of 2025. The green and the purple curves represent the uncertainties on those. You'll notice that the purple curve is slightly higher and starts slightly earlier and is much larger than solar cycle 24. And the green curve is lower and comes later and is about the same size as solar cycle 24. So the official prediction of NOAA and NASA is that solar cycle 25 will be slightly larger than solar cycle 24. Another way you can look at this transition is by assessing the relative number of X-ray bright points in solar cycle 24 to solar cycle 25. Now this is an iron 16 image on the right here, and you can see there are several small bright areas that aren't the major active regions, and I've outlined them here. There are a lot fainter ones, but they're so small and faint it's hard to tell what their magnetic polarity is. So I check what the magnetic polarity is, how they're aligned east-west, what particular polarity is leading, and assign them to solar cycle 24 or solar cycle 25. And then count out how many of each. So let's take a look at the result of that analysis. There are 2 plots here. The one on the left is the old cycle versus new cycle percentage. So when the value goes above 50% on this graph, then predominantly we have solar cycle 25 bright points. When it's below that level, we have predominantly solar cycle 24, and this has followed a relatively smooth transition over the last 18 months, and we're now well above 65% of regions being from solar cycle 25. So obviously we underwent a transition. That transition happened in about December of 2019. There's another way of looking at when minimum was, which is the number of X-ray bright points as a function of time. There's a lot more of these than there are active regions, so it's easier to actually determine when the minimum is. And so this is the number of X-ray bright points of either solar cycle 24 or solar cycle 25. And you can see the minimum was about October of 2019. So that's why I'm guessing that that's about the minimum of this particular transition from solar cycle 24 to solar cycle 25. Clearly, after that point, the number of bright points has been increasing, and as I say, that's mainly due to an increase in the number of solar cycle 25 characteristic X-ray bright points. So what conclusions can we draw from all of this? I think the main one would be we've got to hold on for the ride, because solar cycle 25 could be very exciting. The Sun at the moment is producing 4 times as many new cycle regions as old cycle regions, which is the exact reverse as it was doing a year ago. I believe that solar minimum was likely between July and December of 2019, probably something like September or October of 2019. And we had our first two major flares from solar cycle 25. Both of them were M flares. That's an exciting start to this particular cycle. If the trends that we've been talking about today continue for very much longer, you can certainly say goodbye to any concept of a grand solar minimum this time around. So you can ignore all the channels over the last few years that have been pushing a grand solar minimum, and they were going to slip into an ice age and all the other nonsense that has come about as a result of that for at least another 11 years and probably much longer than that. Their game is up. They haven't told you the truth. They don't understand what's going on in the sun. They haven't told you the truth. So just ignore them in future. So until next time, stay safe and goodbye.